Take two parallel lines of equal length. The parallel lines are placed at the same horizontal position, meaning that the left end of both lines is positioned at x equals 1 and the right end of both lines is positioned at x equals 4. Let's call the vertical distance between the two parallel lines the height, and we can call the length of the bottom line the base, since it is the same as the top line. Now let's label both ends of the bottom line. BL for bottom left, BR for bottom right, and then we can label both ends of the top line. TL for top left and TR for top right. Because the left end of both lines are in the same horizontal position, the horizontal distance between top left and bottom left, TL and BL, is 0. The same can be said for the right end of both lines. The horizontal distance between top right and bottom right, TR and BR, is also 0. Now let's move the top line over to the right by x plus 1. We can see that the horizontal distance between TL and BL is no longer 0, and that the distance between TR and BR is no longer 0. If we look carefully, we can see that the distance between TL and BL is now 1, because BL is at x equals 1 and TL is at x equals 2, and we can see the distance between TR and BR is 1, because BR is at 4 and TR is at 5. So if the two lines are not placed at the same horizontal position, this means that the horizontal distance between top left and bottom left is the same distance between top right and bottom right. They both have the same horizontal distance. This fact about parallel lines will be very helpful when we're trying to prove that the area of a parallelogram is base times height. So now we can go about proving this. Let's add in our parallelogram. Starting at top right, draw a vertical line downward the distance of the parallelogram height. Beginning at bottom right, draw a horizontal line ending at the vertical line we just created. Starting at bottom left, draw a vertical line upward the distance of the parallelogram height. Now, beginning at top left, draw a horizontal line ending at the vertical line we just created. Notice that the green lines represent either the horizontal distance between bottom left and top left, or the horizontal distance between bottom right and top right. We showed earlier that length or that distance is the same, so let's label both of these green lines x1. The result of adding these two pairs of lines is that we've made a rectangle with a base of b plus x1 and height which is the same as a parallelogram h. Then the area of the rectangle, let's call the rectangle R, equals b plus x1 times h. We won't be needing the x-y axes from here on, so we can get rid of those. Also, we won't be needing the labels for the corners of the parallelogram, so let's get rid of those. Notice that the rectangle is made up of three shapes now: the parallelogram and two triangles either side of it. This means the area of the rectangle, b plus x1 times h, is just the sum of the areas of these three shapes, the parallelogram and the two triangles. If we remove the sum of the two triangle areas, the remaining area will be that of the parallelogram. And we can easily figure out the area of the triangles because we have the height and base of both of them. First thing to notice is that our triangles look similar. They're both right-angled triangles. They also both have the base, x1, and they have the same height. In fact, these triangles are congruent. They're exactly the same size. We can figure out the area of these triangles using the formula for the area of a triangle, which is half base times height. Given that the triangles are identical in size, let's call them T, and let's use a label for the parallelogram P. The area of each triangle using half base times height is 1 over 2. Well, the base is x1, so let's do x1, and the height is h, but there are two of them, so that equals 2t, two triangles. The 2 cancels with the 1 over 2, and that means that two triangles, that is 2t, equals x1 times h. Now let's just clean this all up a little bit. In order to calculate the area of the parallelogram, we need to subtract the area of the two triangles from the area of the rectangle. But first, let's expand the rectangle. R, which represents the area, equals, well, first of all, it's BH, BH plus, and then x1 times h. So in order to find the area of the parallelogram P, we need R minus 2t, which is the two triangles subtracted from the area of the rectangle. Let's do that over the other side where we have more space. P equals R, which is BH plus x1h minus 2t, which is x1 times h. Notice that we have x1 times h and negative x1h, so these two cancel, leaving bh, which means that P, the parallelogram area, equals bh, which is base times height, and that is exactly what we were trying to prove and show, that the area of a parallelogram equals base times height.